Good morning to all the students. Welcome to the physics class. Students, in the last lecture we discussed about the potential energy of system of charges. So we considered that there are n number of charges and and we find out the expression for that. Now students, our next topic is potential energy in an electric external field. Now students, if there is any external field and we let any point P in that external field and we want to find out the potential work done for that point, then we can calculate it by just multiplying charge and potential of that point. So as you can see here, we have considered a point P where the potential is V. तो हमने कोई पॉइंट P मान लिया जहाँ पे पोटेंशियल कितना है V. अब स्टूडेंट्स, ये जो पॉइंट P है, this is in external field E. So students, here what will be the work done to moving this any charge from infinity to that point P. Now students, the work done, as we know, is equal to charge into voltage. So W is equal to QV, where Q is charge, unit charge, and V is the potential of that point. Now students, whatever the work we done to move this charge, this unit charge Q from infinity to this point will be stored in the system as the potential energy. So work done is stored as the potential energy of the charge Q. So now when we have moved the charge from infinity to point P, then the unit charge Q has potential energy, and this potential energy will be equal to the work done. So now we know that work done is equal to QV, so potential energy will also be QV. So we put U is equal to Q. So now we can define potential energy, that electric potential energy of charge in an external field is equal to charge into external electric potential, or we can say vice versa, V is equal to U upon Q. So we got the definition. Electric potential at a given point in an external field is the potential energy of a unit positive charge at that point. So students, now our next expression, write an expression for potential energy of 2 point charges Q1 Q2 separated by a distance r in an external field E. Before this we did the expression for system of charge, but in that there was no external field. But here we have applied an external field and two system of charges are placed inside the electric field, external electric field. Now students, here we consider that the V1 and V2 are the potentials of points Q1 and Q2. where the point charges are located. At that point, the potentials are respectively V1 and V2. Then we know what is the potential energy. Potential energy of two charges in external field can be calculated by the potential energy due to Q1 plus potential energy due to Q2 and plus potential energy due to system of charges Q1 and Q2. Now we know the formula for potential energy due to Q1 in external field E. We know that potential energy in external field is equal to charge into potential of that point. So it will be Q1 V1, and also for Q2 it will be Q2 V2. Now third one is potential energy due to system of charges Q1 and Q2. Now we have already discussed, we have already did the derivation for the two system of charges, the expression we have derived. So according to that, the formula is 1 by 4 pi epsilon naught Q1 Q2 upon my R. So this is the potential energy of two system of charges. Now students, when we add these three, we will get the total potential energy of system of charges, two system of charges in external field E. So formula will be Q1 V1 plus Q2 V2 plus 1 by 4 pi epsilon naught Q1 Q2 upon my R. As you can see in the diagram, this is the diagram of two system of charges in external field. Now students, our next is the electron volt. What is electron volt? So students, suppose we move one electron in the potential difference of 1 volt, then what will be the potential energy? So we know very well what is the potential energy. Potential energy is equal to charge into potential difference. So charge is on one electron, charge is 1.6 into 10 to the raised power minus 19, and we have considered that potential difference is 1 volt. So we put the values. So our energy comes out to be 1.6 into 10 to the raised power minus 19 joule. This we call as 1 electron volt. So 1 electron volt is equal to 1.6 into 10 to the raised power minus 19 joule. So this is the potential energy gained or lost by an electron in moving through a potential difference of 1 volt. If we move an electron from through a potential difference of 1 volt, then whatever the energy gained or lost by the electron is the 1 electron volt, and this is equal to 1.6 into 10 to the raised power minus 19. So this is all about the potential energy. Now in next lecture we will do the potential energy of a dipole. Thanks for attending class.